Okay, welcome to the notes for kinematic equations. Kinematic equations are equations that have been put together that already include all of the math manipulations from Algebra 1 that you would need to solve different problems. It's supposed to make life easier for students, but sometimes it doesn't always work that way. Okay, so what we're going to do is quickly look at what the notes are about, and then we're going to practice trying to determine what equation to use. That's the main thing for today. All right, so our symbols. We're going to use delta x for displacement or distance, and this is based on the x of a graphing situation. You have the x-axis going left and right, you have the y-axis going up and down. So most of our distances will be left and right or toward us or away from us, so we'll use delta x. Now if an object is thrown up in the air or is dropped from up and then falls down, we will use delta y. And remember that positives mean up or to the right, negatives mean left or down. So if an object falls off a table, then their change in their height is their delta y, and it's going to be a negative. They go, say, from 10 down to 0, they'd have a negative 10 as their displacement. All right, velocity is v, and the units will be in meters per second. Then we have acceleration in meters per second squared. Now, velocity also has a positive and negative because it's a vector. So if the object is going left, this is what this one is saying, if the object is going left, then it has an initial velocity that is negative. If as it's going left it slows down, that means the acceleration is to the right. The acceleration is, when the acceleration is in the opposite direction of the movement, then it's going to be negative to that movement. And a negative to a negative is a positive. That's a little difficult, but we'll work on it. Right, if you throw an object up in the air, as it goes up, it slows down because gravity always pulls things down. And so as it goes up, it slows down. That means your acceleration is negative as it goes up. The acceleration is downward. The direction is downward because the velocity slows down as it goes up. Again, we'll work on these things. Time will be measured in seconds. Don't go to sleep on this stuff. You know, it's hard to have a parent conference and we keep saying, well, your child refuses to remember that time is a measurement of seconds. All right. So here are our formulas. Now what I'd like you to do, if you have this worksheet and you're looking at it, this column means it is not the symbols A, delta x, VF, VIT are not solved for, and not one of the givens. We'll show you what we mean as we do this. Okay, so first formula, delta x equals 1/2 times VF plus VI times time. And don't forget this time over at the very end. A lot of students leave that off. Acceleration, this is the normal acceleration equation, VF minus VI over t. And then delta x equals VI times t plus 1/2 times acceleration times time squared. Only the time is squared there. Then delta x equals VF times t minus 1/2 AT squared, or VF squared equals VI squared plus 2A delta x. For the most part, the bottom one and this middle one are the ones we use the most. Okay, so our symbols are delta x or delta y. Both of these are displacement. Okay, sometimes you'll see that as a delta d. And then we have the t, the vf, or that's the vi, then the vf, then the a. So what they're asking you to do is put this symbol next to these numbers and questions over here. So like the first one, 2 seconds. That's a measurement of time, so we'll put a t. So what I'd like you to do is pause the video answer these, and then come back and check what you got. So pause the video now and then do the work and then start the video. All right, 3 meters per second is going to be a velocity. We don't know if it's VI or VF. 6 meters to the right is a delta x. That's a distance, so that's displacement. How far? That's a delta x or a delta y. 4 meters per second squared, that's acceleration. How fast is a v. How long did it take is a time. And how high is delta y. All right, we're going to continue down here. A person swims to the other end of a 20-meter long pool and back. Their displacement is 0. Remember, displacement is where did you end up based on where you began. If you begin exactly where you ended up, then it's 0 displacement. A rock falls 15 meters. Is this vertical or horizontal? Horizontal means if you're sitting there and it's going left to right, it's horizontal. If it's going up and down, then it's vertical. Since it's falling, that will be vertical. And the displacement. It's easier sometimes if we show you this on a ledge. The object is up here at 15 meters, and then it's going to fall and hit the ground. So it lost 15 meters. Negative 15 meters is the displacement of the rock. A car moving 12 meters per second stops, okay, and it wants to know what the VF is. Anytime you stop, that means your VF is 0. And then you throw the rock into the air and catch it as it returns, and that means that your displacement is going to be 0. Come back right to where you started. All right, over here. Choose the correct kinematic equation. All right, our variables, we have the acceleration, so we have this guy. We have the VI, that's that guy. We have the VF, that's that guy. And we have the delta x, that's these two guys. So what's left? What's missing? We're missing time. So if you look back on the front page, it tells you that when time is not used means not solved for and not one of the givens. So these are our givens and what we're solving for. You have to write down what you're solving for, and if you don't, then you mess up on these things. So we use the equation VF squared equals VI squared plus 2 times A times delta x. Now you can write that to show you that everything gets multiplied over here on the right. You can put everything in parentheses to show your multiplication. You don't have to, because any variable side by side means multiply. Okay, the second one, variables are A, T, VF, and delta x. The one that we're missing is the VI. So which equation on the front do we use when we're missing VI? And again, missing means not solved for. Delta x isn't missing, it's being solved for. VI isn't being used. That equation is delta x equals VF times T. I'm going to put it in parentheses. Plus 1/2 times A times T squared. Oh, I wrote that wrong. It's not plus, it's minus. VF times T minus 1/2 times A times T squared. All right, third one. We have the A, the VI, the VF, and the T. We're missing the A. And the formula to use is, we have the A. We're missing the delta x. Okay, and that is the regular acceleration equation. A equals VF minus VI over T. Right, so this is how they look in a word format on a multiple choice or on in a problem. This is how you're going to see and solve for these things on tests and on worksheets. So as you read through, underline all the numbers and the word that follows or the symbol that follows. That tells us the unit. Seconds are units. In 10 seconds, a car accelerates 4 meters per second squared to 60 meters per second. How fast was the car going before it accelerated? So you have to read through this, underline all your numbers and the units after them. Underline what they ask you to solve for. How fast was the car going before?
Teacher, pardon this interruption. All seniors should be making their...
Okay, so everyone knows that seconds is time. So just because this is a science class, don't act like you've never read anything. Seconds is time. Accelerates is the word just before 4 meters per second squared. So it tells you that 4 meters per second squared is acceleration. It will almost always tell you everything except time, distance, and speed. All right, 60 meters per second. You have to understand that meters per second is a velocity, but is it the initial or is it the final? So you have to read, in 10 seconds a car accelerates to 60 meters per second. That means that's the last thing that he does. And they ask you how fast was he going before he accelerated, and that means they're looking for the VI. So we write our symbols. T equals 10, A equals 4, VF equals 60, and VI is a question mark. So we have the T, the A, the VF, and the VI. We're missing the delta X. So you look back on the front, and you see the delta X is not used when we use A equals VF minus VI over T. Again, not used means what is it that isn't one of the givens and you're not asked to solve for. Students who don't pay attention always forget to write down the symbol for what you're looking for. Okay, and we would rearrange this to solve for VI. All right, on the right-hand side here, it says an object moving 2 meters per second experiences an acceleration of 3 meters per second squared for 8 seconds. How far did it move in that time? Okay, so we're moving 2 meters per second. That's going to be a velocity. Is it our initial or our final? Well, we're moving and then we experience, so that means it's our initial. Notice again that it tells us the acceleration is 3. So that means the 3 meters per second squared is the acceleration. It told us that. We don't have to memorize it. And then 8 seconds. Hard to explain to your mother why you don't know that 8 seconds is a time, because that's everyday life. Nothing changes. How far did it move is going to be a distance. That's a distance, and we're going to use that as the triangle X. Okay, triangle X. So VI is 2. A equals 3. T equals 8. And we're looking for delta X. So delta X equals question mark. So what formula are we going to use when we have the VI, the A, the T, and the VX? We don't have VF, and so you look at that formula, and it's VI times T plus 1/2 A T squared. Okay, next one, an object at rest. What does at rest mean? Okay, that means that your VI is 0. It starts to accelerate. If it travels 40 meters, that's a distance, so that's going to be delta X. To end up going 20 meters per second, that means that is your VF. We're looking for acceleration. All right, so we have VI. We have delta X equals 40. We have VF being 20. We're looking for acceleration. That means we don't have time, so your formula is VF squared equals VI squared plus 2 times acceleration times delta X. All right, so see what you can do on the next 3 problems. See if you can break them down. I will help you on 11 and 12. Remember that if something stops, that means the VF is 0. And on number 12, if it starts at rest, the VI is 0. So what I'd like you to do is pause the video, go through and see what you can do, and then I'm just going to put the solutions in here. I'll have them underlined when you come back and have the final equation that you should be using. So go ahead and pause the video now. All right, a model rocket climbs 200 meters. That's a delta y. I'm just going to put it as delta x. 4 seconds is time. It was moving 10 meters per second. That's vi to begin with. Final velocity is vf. So we have a delta x equaling 200, t equaling 4 seconds, vi equaling 10, vf being solved for. So we have the exact same thing. No. We have delta x equals 1/2 times vf plus vi times t. We don't have acceleration, and the equation we use when we don't have acceleration, we're not looking for it, and that's not given. We use delta x equals 1/2 vf plus vi times t. And it doesn't matter if you write it as vi plus vf or vf plus vi. You'll get the same number. Then we have a car stops in 120 meters. That's delta x. It accelerates at -5. How long did it take to stop is time. So we have vf equaling 0. We have delta x equaling 120. We have a equaling -5. And we have t is what we're looking for. So it's delta x equals vi times t plus 1/2 times a times t squared. If you drop 20 meters, that means it's going to be a delta y. I'm just going to write it as delta x for today. It started at rest, so vi is 0. It's going 20 meters per second. That is vf. What is its acceleration? So we're looking for a. So we have delta x being 20. We have vi equaling 0. We have vf equaling 20. And we're looking for acceleration. So change colors here so it's easier to see. That means we have the vf, excuse me, we have vf squared equals vi squared plus 2a delta x. All right. So tomorrow what we'll do is we'll practice putting numbers in here and see how to solve. Now, every once in a while on this, we're going to ask you to solve for the acceleration using this equation. When we do that, we will give you the manipulated formula. So you don't have to worry about the math, so that we take some of the problems with math out of here so that we're concentrating on learning what the concept is on physics. All right, good luck, guys, and we'll do some more math in the future. Thank you.